Good morning. We are going today to discuss on the helicopter rotor types. If you recall, we discussed the articulated helicopter hinges, articulated helicopter rotor, and we said that in a normal articulated helicopter, the conventional rotor hub, we need the pitch hinge, the drag hinge or the lead leg hinge, and the flap hinge. Let's try to see what other helicopter rotor system exist. Here are the following helicopter rotor systems that you can see mostly on a helicopter. The tethering helicopter. It is the most simple rotor helicopter, rotor hub helicopter, and it involves two blades which are interconnected to a floating hub, and the blades are freely to flap up and down. The articulated rotor, it involves the flap, the lead leg, and the feathering of the blades. The hingeless rotor, it involves the feathering of the blades. It is also called rigid or a semi-rigid rotor. There is also the so-called semi-hingeless helicopter where we still have the flapping and the feathering of the blade. A bearingless helicopter is a truly hingeless helicopter rotor where no hinges are mechanically built, and we have the freedom of these blades in the material where we put in a hub. Examples of our articulated rotors with offset flapping hinges. The articulated rotor system appeared in fact at autogyros in 1920. As I said to you, the Sierva invented the flapping hinge and is the oldest and most widely used type of rotor system. The blades in an articulated rotor can move up and down, they can flap, they can move back and forth in a horizontal plane, they can lead lag, and they can change in the pitch angle, so tilt of the blade. Here you see, for example, the Sikorsky S-58, the fully articulated helicopter, with a classical flapping hinge, the feathering hinge or the pitch hinge, and the lead leg hinge. Other examples of articulated rotor. You see, for example, here the Aerospatiale AS341, where the flapping and the leg hinge are separated. Here is the flapping hinge and here is the lead leg hinge, and here you see the swash plate. As I said, usually in order to avoid ground resonance we need to introduce a lead leg damper, and here is the feathering. And you see here also the Sikorsky S-58, where the flapping and the lagging hinge are together. They are put on the same place. This is the articulated rotor of the Chinook, the CH-47D helicopter. And you see again the lead leg hinge and the lead leg damper, the pitch changing and the hub, and this is the flapping of the helicopter. As you see, the complexity of an articulated rotor, it is composed of all these hinges which are connected into them and involves many parts. I forgot to say that the advantages of an articulated rotor are that they give you high control power and you can put any number of blades that you want. However, it means a high drag, we need a lead leg damper in order to prevent the ground resonance, and we have many bearings that need maintenance. So they are expensive in that sense. The hingeless rotor. Here is an example of the Lockheed H-56 Cheyenne helicopter, which is unhingeless. You see that actually it had a virtual flapping hinge and the feathering hinge, which is a door hinge feathering bearing. There was a tension torsion wire pack in the rotor hub. The advantages of the hingeless rotor, it is that it has an improved control power. It has an improved in vibration control, and there is no risk of ground resonance. The disadvantages are that they are actually more expensive and they have some instabilities which are quite difficult to avoid and in a design. Another classic example of a hingeless helicopter is the Volkov, the BO-105, which is a rigid hub with flexible blade roots. So the rigid hub, you see actually the virtual flapping hinge, the virtual lead leg hinge, and only the feathering bearing is here. And this is the full rotor hub of the BO-105. The Lynx helicopter, it is also a very thought hingeless rotor, and it requires dampers in this case to prevent the ground resonance. So you have the feathering bearing and the virtual flapping hinge and the virtual lead leg hinge. It involved the so-called dog bone design, where a match of the stiffness in torsion was made in order to avoid aeroelastic instabilities. The Western Lynx, it also was aerodynamically designed. The blades were aerodynamically designed. And in fact, the combination of this hingeless rotor hub and the advanced blade composites gave the Western Lynx the absolute speed record of helicopters, which is approximately 400 kilometers per hour. The blades were the so-called burp blade that I will mention later, British Experimental Rotorcraft Program. Aerospatiale Dauphin is also having a hingeless hub with elastomeric flexibility. You see here the feathering motion, the virtual flapping hinge, and then an elastomeric spherical thrust bearing, which was required in order to prevent the ground resonance. The bearingless rotor. There is actually all the axis, all the hinges have been eliminated. So we do not have neither the pitch hinge. And this hinge has been replaced with a flex beam torque tube arrangement, which allow the blades to have their freedom. So you see here the flex beam, which allows the blades to move up and down, lead leg, and also to pitch. And this was in a torque tube. In this way, I end this course of giving you the main rotor types, the classic articulated helicopter and the hingeless and the bearingless helicopter.